Okay, here we want to use an alternative to integration by parts called the tabular method. Okay, now when we see the integral 2x cubed times the sine of 2x, we should immediately recognize the need for integration by parts because we have product. And remember, integration by parts is used especially to find the integral and find the antiderivative of integrals that contain products. But here, we should also recognize that once we see this is raised to the third power, we would have to go through the process, of integration by parts 3 times, okay, for it to work itself out. So one useful thing we do is called the tabular method. Now, it's still pretty much integration by parts, but it's a more efficient version. It reminds me of the difference between adding horizontally or adding vertically. So this is what we do. We still want to use our acronym LIA, logarithmic, inverse, algebraic, trigonometric, and exponential in order to choose U. So 2x cubed is algebraic and sine 2x is trigonometric. So first on the left side, I want to use my 2x cubed. And then on the right side, I want to use my sine 2x. I'm going to come back and put the cubed here. Now, on the left side, this is what we want to do. On the left side, we want to find the derivatives. The derivative of 2x cubed is 6x squared. Okay, the derivative of 6x squared is 12x. The derivative of 12x is 12. And the derivative of 12 is 0. Now I'm going to come back and put my exponents in. So remember, this was 6x squared. Now, on this side, we need to find the antiderivatives. Now, you have to be careful here, especially on the signs, because any mistake on concerning the signs will throw this whole problem off. The antiderivative of sine 2x was negative cosine 2x over 2. Okay. The antiderivative of negative cosine 2x over 2 is negative sine 2x over 4. You have to really make sure we remember our rules here. The antiderivative of negative sine 2x over 4 is going to give us cosine 2x over 8. And the antiderivative of cosine 2x over 8 gives us sine 2x over 16. Okay, so now we're going to go back through and make sure we're doing everything correctly. So on the left side, we're finding the derivatives, and on the right side, we're finding the antiderivatives. Now, this is what else we have to look at. We want to alternate our signs all the way down. That should be plus, that should be minus, plus, minus, and plus, all the way down. Now, another thing that we want to do is we want to multiply diagonally, almost like cross multiplication. As we know, 0 times anything would just be 0, so there's no need to put anything there. Now, once we multiply, as this will give us the results that we're looking for, all right? So now, we have 2x cubed times a negative cosine 2x over 2. Okay, now next we have a negative. Let's put this here. And let's get the right size in. Remember, this is cube. Okay, next, as we're going to have negative 6x squared times a negative sine 2x over 4. Negative times negative is going to give us positive. That's the key. You have to make sure that we're doing this. That's negative 6x squared. I'm sorry, that's positive 6x squared times sine 2x over 4. Okay, now we have 12x times cosine 2x over 8. That's going to be plus for 8. Let's move this over. Okay, and now for the last term, we're going to have negative 12 sine times sine 2x over 16. So as we know, we always want to add our arbitrary constant c. Now, of course, we will have to go back in and reduce this to lowest terms. That goes without being said. Just for the sake of time, we won't do this here. Yeah, but this is how we solve this using the tabular method. So going back, our final answer would be negative x cubed cosine 2x over 2. This will cancel. The 6 over 4 will reduce. So this would be 3x sine 2x over 2. Here, the 12 and the 8 would reduce. That would be 3x cosine 2x over 2. And here, the 12 and the 16 would reduce down to 3/4. So this would be 3 sine 2x over 16 plus c. So that's how we look at our tabular method. And like I said, it's a lot cleaner than integration by parts on this level.